Hello everyone, in this video we're going to pick up where we left off in section 11.6 with quadric surfaces. So we looked at, so far now we've looked at three different types of surfaces in the three dimension. We looked at spheres, we looked at planes, we looked at cylinders, and now we're going to look at quadric surfaces. So the fourth basic type of surface in space is a quadric surface. So quadric surfaces are the three-dimensional analogs to conic sections. Right? Remember our conic sections were like hyperbolas, hyperbola, ellipses, parabolas, those kind of things. Sorry, I just had kind of a brain shortage. So quadric surfaces are the three-dimensional version of that, right? So in general, the equation of a quadric surface in space is a second-degree equation in three variables. The general form is as follows. So second degree means that I see x, the first variable to the second power, b, the second variable to the second power, c, the third variable to the second power. And then what do I see next? I see all the different combinations of the x and y and z put together, right? There are three of them, all to the first power. And then I see every variable by itself to the first power. And then I see a constant at the very end, right? So that would be the general form of the equation. And again, this is for constants a, b, c, d, e, f, g, h, I, and j. So I could have some of those constants be 0 to make some of these variables disappear, which you'll see in a second. But that is the general form. Okay, so there's 6 basic types of quadric surfaces. And again, the traces of a quadric surface are conics, right? That's what we mean by these are the three-dimensional analogs of conics. So I wrote down a bunch of the equations for those 6 different types here for you to have as reference. But I also posted this PDF of the quadric surfaces. This is just the page out of your book, but we'll go through it right now. So this I posted on Blackboard as well, so it's there for you to have as reference under kind of like that tab on your Blackboard which has all of those helpful documents for you. Okay, so an ellipsoid, again, is like the three-dimensional version of an ellipse being like, like an oval. So it looks like x squared over a squared plus y squared over b squared plus z squared over c squared equals to 1. Important things to remember is I have x squared, y squared, z squared all up here. These are all pluses, and I have a 1 on the other side, right? And yeah, that's basically the general picture, and then you see the picture on the left and right of what one of those looks like. So how about a hyperboloid of one sheet, right? So key characteristics of this, I have x squared, y squared, and z squared all appear there, but I have one subtraction sign, right? One of them is being subtracted, and I have a 1 on the other side of my equal sign, right? And so again, this is the, I have, so when I talked about I guess I kind of missed the traces up top here. So what this is saying is the traces, remember that's where they intersect the different planes, is all ellipse, right? So this trace right here would be the trace that is the xz trace, and you notice that is an ellipse. Then the yz trace, which would be this trace right here, that is also an ellipse. And then finally the which one did I miss? The xz trace, which is this guy right here. Did I get that one? So that one, this one right here, I think is the one I missed actually. The xy one is also an ellipse. So now in this case, again, I have y squared, x squared, z squared. I have one subtraction symbol, and I have an equal sign. So when I go to do my traces, right, the trace to the x, so the one thing I should note as well is that the axis of the hyperboloid, again, where this tube is kind of going around, corresponds to the variable that's being subtracted. So in this case, z is being subtracted, so that's why this is kind of like a tube around the z-axis. So in this case, all of our traces will be, some of our traces will be different, right? So this trace on the XY axis is an ellipse. But the traces that are on the YZ and the XZ are going to be hyperbolas, right? Remember those shapes that look like that. So that's called a hyperboloid of one sheet. A hyperboloid of two sheets means that I have, again, x squared, y squared, and z squared, and I have all subtraction, and I have 1 on one side, right? So this is a hyperboloid of two sheets. So obviously it has quite a different shape. Why is it called two sheets versus one sheet? Because it's like in two different pieces, right? And so in this case, once again, if I were to take the this trace, right, in either case, I'm going to get an ellipse. But when I do the trace with the, say in this case, the YZ trace looks like this hyperbola. And then if I did it in the YZ trace, oops, sorry. Boop, boop, boop. So now if I did it, if I did a different trace, I would get like this guy here and this guy here, or that guy there and that guy there. But in other words, two of the traces are hyperbolas and one of the traces is an ellipse. So an elliptic cone, right? It's the only one that has cone in it. And a cone has x squared, y squared, and z squared. But it has one of those being a subtraction, and it has a 0 on the other side, right? And oh, one thing I should have noted in the hyperboloid of two sheets, the guy that's positive, right, in this case it's the z, is the one that, again, that we're kind of focused on, right? We go up and down the z axis. So the cone, the one that's being subtracted is, again, where we're focused on. So in this case, z is being subtracted, so that's where we put the cone around, or the elliptic cone around. Again, one of my curves is going to be, one of my traces is going to be an ellipse, and the other two traces are going to be hyperbolas. For elliptic paraboloid, again, this is where I have one of my variables to the first power, the other two variables to the second power, and a plus sign, right? Whatever one is not being squared is going to be where we're kind of centered about, where the axis is. And then I have, again, different traces. My traces in this case are either going to be a ellipse or a parabola, right? And then a hyperbolic paraboloid is going to be, again, the same idea, where I have z, or 1 to the first power, the other 2 to the second power. This time I have a minus sign. Again, whichever one is not taken to the first power is my axis. But in this case, my traces are going to be a parabola here. If you notice, I have a parabola here, if I could draw it. And then my other two are going to be this, and this would be a hyperbola. And then this would be a parabola. So I have two parabola traces and one hyperbola trace, or hyperbola trace. Okay, so those are my quadric surfaces. Okay, so now let's try to classify and sketch each quadric surface. So in order to do that, we need to try to put it in standard form, right? So we want to write in standard form. So right now it's 4x squared minus 3y squared plus 12z squared plus 12 equals 0. Notice we have this constant 12, so I can move that to the other side. 4x squared minus 3y squared plus 12z squared equals to negative 12. And if I look at all these equations for the quadric surfaces, they either have equals to 1 or 0, or just the one variable that's not being squared. In this case, we have all of our variables being squared, so it's not either 5 or 6, right? And it actually is not even going to be a cone either. So we need, in other words, we need to get 1 on the right side of the equal sign. So now I need to divide by negative 12 to get 1 on the other side of the equal sign. So here I get negative x squared over 3 plus y squared over 4 minus z squared, and I'm going to be a little redundant and put over 1, and then I would get equal to 1. Right? So this is the equation in standard form. I could rewrite it because I have some minuses here, so I could rewrite this as y squared over 4 minus x squared over 3 minus z squared over 1 equals to 1. And again, this is our standard form. So now we need to look at our equations and see which one this matches up to. So I know that right now I have highlighted, now I've highlighted the 3 possibilities it could be. In this case, I have 2 minus signs. So I know that it is going to be the hyperboloid of 2 sheets. Right? I know it has to be this guy right here. This guy right here. Right? So this is a hyperboloid of 2 sheets. And then it's going to be with what axis? Remember, the one that's not being, the one that doesn't have a subtraction sign, right? So this one is, in this case, it is the y-axis, right? The variable whose coefficient is positive is going to be our axis. So we'll say with y-axis as the axis of the hyperboloid. Okay. So now what we should do is we should look at the traces, because that will give us kind of an idea of how to draw this. So now we have, let's look at the XY trace. So the XY trace, remember, that's when z is equal to 0. So if z is equal to 0, this ends up looking like y squared over 4 minus x squared over 3 equals to 1. And you may not remember, but this is the equation of an ellipse. Or sorry, not an ellipse, a hyperbola. Or hyperbola. I think I always pronounced that a little incorrectly. I apologize. So that's a hyperbola. So the XY trace is a hyperbola, or hyperbola. Let's try the YZ trace. So the YZ trace is going to be y squared over 4 minus z squared over 1 equals 1. So again, that is another hyperbola. And then the XZ trace, that one is going to be negative x squared over 3 minus z squared over 1 equals 1. So in other words, it looks like x squared over 3 minus or plus z squared over 1 equals negative 1. In any case, that's nothing, no special trace, right? So if I were going to highlight this, since we already kind of have it drawn to the left, the XY trace, remember that is going to be a hyperbola. So the XY trace would be this piece right here, right? And this piece right here. And as you can see, that is a hyperbola. And then if I were going to look at the YZ trace, we'll do it in green here. That would be, again, on the YZ, this would be like this piece right here and this piece right here, right? And again, that's another hyperbola. Okay. And as you can see here, there's nothing going on in the XZ, no special trace. All right, so now let's look at another one. Classify and sketch x minus y squared minus 4z squared. So notice here that I have only one of my variables is to the first power, right? So that's going to correspond to one of the paraboloids. We just need to figure out which one it is. So what we should do in order to put it in standard form, right, we're looking at either this one or this one. We should bring the variable that isn't taken to the or that's taken to the first power by itself, right? So here I should write x is equal to or the original guy is x minus y squared minus 4z squared equals 0. Again, we know that's going to be a paraboloid. I think that's what they're called, right? Paraboloid. And so I'm going to leave the x on one side and get y squared minus or plus 4z squared. Now it's in standard form, right? So again, what is this? This is going to be a, and we got to figure out which one it is, right? There were two different paraboloids. So this one has a plus sign, right? So the paraboloid with the plus sign is the elliptic paraboloid, right? So that's what this one is. This is an elliptic paraboloid. And then the axis that's not, or the variable that's not being squared is where the axis is, with the x-axis as its axis. So once again, we're going to find our traces. So if I have my xy trace, my xy trace is going to be x equals y squared. X equals y squared, we know, is a parabola. Then we can have the yz trace. And the yz trace is going to be y squared plus 4z squared equals to 0. So in this case, what we can do, it's a little bit awkward, but that doesn't really tell us anything, right? So instead of looking at the yz trace, what we can do is we can say, we're going to look not at the yz trace, but parallel to the yz plane with, let's just say, x equals to 4. So in this case, if I let x equals to 4, then I get 4 is equal to y squared plus 4z squared. And I know that this guy is going to be parallel to the xy plane or the xy trace because it only has x's and z's in it. It only has y's and z's in it, no x's. And now if I divide by 4, I end up getting 1 is equal to y squared over 4 plus z squared over 1. And then what is that equation? That's an equation of an ellipse, right? So in other words, at x equals to 4, I have an ellipse. At x equals to 2, I would have another ellipse. At x equals to 5, I would have another ellipse. So I'm going to have a bunch of ellipses there. And then now if I try, what's the last one, the xz trace, then I end up with x is equal to 4z squared, which again is another parabola. Right? So if I were going to draw these, let's make this blue, the xy trace. So the xy trace would be this parabola right there. Again, it's not really the yz trace because we didn't really get anything special from that, but we saw at x equals to 4. So here is the x value 4. We draw an ellipse. That is going to be kind of our yz trace. And again, you'd get another one, you get another ellipse here at like x equals 1. You get another ellipse right here at the end at like x equals 10, right? But we get a bunch of ellipses there. And then if I did, the last one here is the xz trace. So that would be this guy right here. And again, that's an ellipse. Okay, so finally, let's classify and sketch this last surface. So this last surface is going to be one where this is going to be not centered at the origin, right? In all the examples we looked at, and even when I looked at this quadric surfaces, notice it was just x, y squared and z squared, right? It wasn't x minus 2, y minus 2, z minus 5 or something like that. So all of these were centered at the origin. If you look at the pictures, they're all centered at the origin. But that doesn't necessarily have to happen, right? They could be centered anywhere. And so this is going to be an example where it's going to be centered somewhere else, because I'm going to get like an x minus something, a y minus something, and a z minus something all squared. Right? So what I'm going to have to do in this case is complete the square now 3 times. So here I'm going to collect all my terms together. So I'm going to collect x squared and minus 4x together. And then I'm going to collect 2y squared and 4y. And then I'm going to collect z squared and minus 2z. And then I'm going to go ahead and pull the 3 to the other side. So now I'm going to complete the square 3 different times, right? But before I can complete the square on the y's, I'm going to have to factor out a 2. Okay, so let's complete the square for the x's. Right, so in order to do that, I get x squared minus 4x. I take half of negative 4, which is negative 2, and I square it, which is positive 4. So I'm going to add 4 and subtract 4 to keep it balanced. Now I'm going to factor out a 2 from here, so I get y squared plus 2y, because I can't complete the square until it looks like that. And now I'll complete the square with z, so I get z squared minus 2z. And then now I take half of negative 2, which is negative 1, and I square it, which is positive 1. So I get plus 1 minus 1 to balance that, and then equals to negative 3. Right? So now this right here is x minus half of the middle term, which is minus negative 2. So x minus 2 quantity squared, and then that minus 4. Right? I completed the square there, and then I have the leftover minus 4. And then plus, now I have to complete the square here. So I get y squared plus 2y. Half of 2 is 1. Square that, I get 1. So this is plus 1 minus 1. And then plus, now I complete the square here. So I get z minus 1 squared. And then the minus 1 and equal to minus 3. So now I get x minus 2 squared minus 4 plus 2, and then this I complete the square, so I get y plus 1 squared. And then remember, I have this minus 1 here, but I can't just write minus 1 because it's being multiplied times that 2, right? So in other words, I need to distribute this 2 there, so I get minus 2, and then plus z minus 1 squared minus 1 equals minus 3. Now, if I pull my constants over the other side, I'm left with x minus 2 squared plus 2y plus 1 squared plus z minus 1 squared equals to positive 4. And now, remember, so I know that this is centered at the point 2, negative 1, 1, and I need to figure out which one of these shapes it is, but again, which one of these quadric surfaces it is, but again, I have either 1 or 0, or the variable that's not being squared. In this case, all my variables are being squared, and it's not 0 on that side. So I know it's either going to be an ellipsoid, hyperboloid of 1 sheet, or hyperboloid of 2 sheets, but in any case, I need to get 1 on the other side. Right now it's 4. So I need to divide everybody by 4. So I end up getting x minus 2 squared over 4 plus y plus 1 squared over 2 plus z minus 1 squared over 4 is equal to 1. So I have all my variables squared, everything's being added, and I have 1 on the other side. So this is in fact an ellipsoid. And this time it doesn't have the center of the origin. So we'll say with center. And the center is going to be 2, because remember, it's what's being subtracted from each one of these variables, right? So 2, negative 1, and positive 1, right? So it's an ellipsoid centered at 2, negative 1, positive 1. And that's the picture right there. That is the drawing of this. All right, that's all I have for this video. Thank you.